Next, we're going to learn how to do calculations using significant figures. The first thing we have to consider is how to round these values. So imagine that we took some measurements and we needed to do some calculations with them, and we need to also round the calculations to the correct significant digit. So imagine that we did our calculation and we ended up with the number 1.23456. And imagine that the last significant digit is this 3. So we want to round to the hundredths place. So to figure out what to round to, we look to the number to the right. Because the number to the right of the last significant figure is a 4, then we're going to retain that 3. So to round that number to that 3, we would round 1.23. And that would be our value. However, let's say that we had the same number, but the last significant digit was this 4, and we wanted to round to the 4. So then we look at the next number. The next number is a 5, so we're going to round that 4 up to a 5. So that number is going to be 1.235. So these are just basic rounding rules. I'm sure they are familiar to many of you already, but I wanted to do a little bit of a review just to make sure that we're all rounding the same. And I would also like you, over the course of this class, to round only the final answer. Don't round every step in between, because in terms of accuracy of experimental measurements, that could introduce more numerical error into your answers. So the next thing we want to do is talk about multiplication and division. So what are the rules for multiplying and dividing with Sig Figs? So for multiplication and division, the answer should have the same number of significant figures as the value in the calculation with the fewest number of Sig Figs. So what does that actually mean? Imagine that we are trying to multiply, Imagine that excuse me. There we go, there's our pen. So imagine that we were trying to multiply the following numbers. We have 7.34 times 6.2 times 10.44. So let's pause for a moment and ask ourselves how many significant digits are in each of these values. So this first number here has 3 sig figs. All 3 are non-zero numbers, so they're all significant. 6.2 has 2 sig figs, again, all non-zeros. And then finally, we have this number here. So this one's a little bit more confusing. So we have 4 non-zero numbers, and then we also have 2 interior zeros. Remember that interior zeros are significant, so that means that this value has 6 significant digits, or 6 significant figures. So I'm fine with you using a calculator in this class, so you can either multiply this out by hand or with a calculator. And when you solve this problem, you should get the following number. You should get 45983.10352. So that's a really long number, and we don't want to write all of the digits because not all of them are significant, because whatever measuring techniques we use to make these measurements, again, imagine that these are all measurements, none of those values actually were precise enough to give us all of these decimal points. So what we want to do is we want to round to the proper significant figure. with multiplication and division, it's the number with the fewest number of sig figs. So out of our 3 numbers we started with, the 6.2 has the fewest number of sig figs. It only has 2 sig figs. So that means we're going to round our final answer to 2 sig figs. So what does that look like? Well, we know that we want to round to 2 significant figures, so we start from the left. We know this 4 is significant. We know the 5 is significant. We only get 2, so those are the only 2 that we can use. So rather than just round to 46, if we did that, our decimal wouldn't be in the right place. So what we can do is we can either write 46,000. Remember that 5 rounds up because it's next to a 9. But again, that can be a little bit ambiguous because we don't really know where our decimal point is. So the best way to represent this number is to put it in scientific notation. And we do that by writing 4.6 times 10 to the 4th. So there we have our 2 significant figures, and we still have the 10 to the 4 as our placeholders. And if you need a little bit of review on scientific notation, the way you do that is that we know, even though the decimal isn't written, we know that if it were written, it would be here after the zeros. In order to get there, we have to move to the right 1, 2, 3, 4. So that's how we got times 10 to the 4th. So that's going to be our answer there. So I have a whole series of practice problems for you. Go ahead and try these on your own. Put the answers in the comments section so we can discuss them as a class. Now on to addition and subtraction. The numbers for addition and subtraction are a little bit different. So what we're going to do is we're going to round the answer to the decimal place of the number with the fewest decimal places. So basically we are rounding to the least precise value. So first I'm going to do an example with addition, and then I'll do an example with subtraction. So for addition first, imagine that we have 2.345 plus 0.07 plus 2.9975. So again, you are welcome to use a calculator for this, but I highly recommend when you're doing addition and subtraction to line up all the decimal places because it's going to be much easier to figure out what your significant figures are. So the answer to this, even whether or not you're using a calculator, it's up to you, but the answer is going to be 5.4125, but we know we're not taking significant figures into account with that answer, so we have to account for our sig figs. So what we're going to do is we're going to look for the value with the fewest decimal places. So in this case, it would be the 7. So there are only 2 place values after the decimal in this number. In our first number, we have 3 places past the decimal. In this number, we have 4 places past the decimal. So since the 7 is the fewest, we're just going to draw our line straight down, and our answer is only going to go 2 spaces past the decimal, just like our number with the fewest number of decimal places. So that is going to make our final answer round to 5.41. And that'll be our final answer for that one. For subtraction, we're going to do the same thing. So imagine we are subtracting 5.9 minus 0.221. So again, if you want to use a calculator, you are welcome to. But our answer is going to be 5.679. In this case, this first number has the fewest spaces past the decimal. It only has 1 place past the decimal. The other number has 3. So we're going to round to 1 place past the decimal point. So that's going to be to this value here. But notice that in this case, The number to the right is a 7, which means we have to round up. So that means that our final answer is going to be 5.7. So again, I have some more practice problems for you. Solve those on your own, put the answers in the comments. A few words of advice. You're going to want to remember to follow the order of operations. For multi-step problems, make sure you're keeping track of the significant figures for each step, even if you're not rounding there. So keep track of sig figs throughout the problem. And then finally, round your answer at the very end of the problem. Okay, best of luck with your practice.